will be telling us about Z of 3 Lyman alpha nebulae.
Thanks. Let me first thank one of our organizers for putting me in this relatively sleepy and subdued state. As my kids and students can tell you, I rarely stay up past midnight. Second, let me thank the main organizer, Colin, for letting me squeeze this talk into the lineup here. About 2 weeks ago, this gentleman, Fabrizio Aragoni Battaglia, we call him Fab, shared a result with me that I thought this crowd would be interested in, so I asked at the last minute to present it. The main result is here on the right. It will be a discussion here on what we call ELAN, or Enormous Lyman Alpha Nebulae. A bit of a goofy acronym, perhaps, but I'm pretty sure the first skis I ever owned were by ELAN, and therefore I like the acronym. I have 5 slides and 3 asides. Here's the first aside. I think on Monday, one of the presenters, I think it was Zachary, raised some doubt about the observed bimodality in the metallicity distribution function of low redshift Lyman limit systems. Mouthful. If you're interested in that topic, I refer you to this paper which appeared today. And if you still have concerns about whether there is a bimodality, please see me afterwards. Now to the second slide. The talk, as I said, is on ELAN, and we're motivated, in part at least, by wonderful visualizations like these, which predict baryonic halos around dark matter in dark matter halos, baryonic gas in dark matter halos. I'm told that the great physicist Paul Schechter has great reasons to believe that this is all a hoax. But as a proper observer, I think it's our duty to go and test this paradigm as best we can, and that's indeed what we're up to. As my second aside, Paul, if you happen to be listening to this presentation, it's on. So you probably appreciate that our preferred technique thus far has been to use luminous background light sources like quasars and the light from them to study the gas in absorption. As Marcel emphasized in his talk, we can only probe a single halo at a time at best. And so the inferences that we draw are statistical, but I think we've made some nice progress with this approach. Here I show some results from the COS Halos survey. I'm plotting the H1 Lyman alpha absorption lines for about 40 halos. And here on the x-axis is the distance from the center of the galaxy in that halo to the central galaxy to the sight line probed by the quasar. And the y-axis is the stellar mass of the galaxies in those halos. And then even the non-experts in the room probably can appreciate that there's strong absorption from hydrogen gas throughout the halos of these galaxies. And indeed, I could extend, I won't, but I could extend this figure to about there, 300 kiloparsecs, and the result would hold. And I could extend the y-axis about an order of magnitude in each dimension, and the result would hold. And I could shift from redshift 0.2 to redshift 3, and the result would hold. So statistically, at least, we know that there is a major reservoir of cool hydrogen gas around galaxies, in the dark matter halos of galaxies, what we call these days the circumgalactic medium. Now, unfortunately, this technique will probably never provide the ability for us to infer whether that gas is in a stream, or, as Avishai tells us, 3 streams. To do that, we would very much prefer to image the gas directly, and that's where the ELAN come in. About 2 years ago, Sebastiano presented at this workshop his discovery of the Slug Nebula, so named because of the yellow color and funny morphology. And you can now see where the E comes from in ELAN. This thing is enormous. It's a 0.5 megaparsec physical, clearly exceeding the size of the halo of the dark matter halo hosting that quasar. As I emphasized at the end of yesterday's session, we had already inferred this from the absorption line technique. And indeed, we didn't expect, nor do we commonly find, such enormous and bright nebulae like these. But nevertheless, here is the first clean example. As a spectroscopist, when I see this, my immediate reaction of seeing a nice Lyman alpha narrowband image like this is, let's get a spectrum. Camille, are you here in the back of the room there? If you're interested in spectra, wonderful spectra of the slug, go see Camille. She's got some great data. Chris Martin, are you in the room? Chris Martin? He's published some great data from that same CWI that Zhang just referred to. It's an IFU, optical IFU. And he's put forth a rather provocative interpretation that the majority of this emission is coming from a large, 100 kiloparsec, rotating disk. You can ask him about that. Now that brings a smile, of course, to the face of Arthur Wolf, rest in peace. Which leads me to my third aside, if I may. Marcel didn't have a chance during his presentation, but Art's last hurrah was to detect 158 micron emission with ALMA of redshift 4 damp Lyman alpha systems. It's unfortunate he didn't survive to see them himself, but I'm sure he takes solace in the fact that his last PhD student is the one leading that discovery. Okay, but back to my talk. Spectroscopy, here we go. Not of the slug. I bring you back to Fab's result and Fab's nebula. He hasn't named it yet, so I'm going to call it the Fabulous Nebula. Thank you, Doug. This is a narrowband Lyman alpha image of that nebula. And the savvy observers in the crowd, there are a few, I think, once they see that this is from the VLT Muse, it is, will appreciate a few things. First of all, it's got to be at high redshift because Muse only starts around 5,000 angstroms. And indeed it is. It's around redshift 3.1. So it's the highest Elon detected line. And it's very bright. This is the surface brightness down here. So the red regions are a few times 10 to the minus 17. That's bright, you theorists. And it's probably the most luminous nebula in the known universe. Not sure we know that for sure yet, but we're working on it. And the third thing, and most important thing the savvy observer will appreciate, is this is not a narrowband image from a narrowband filter. This is a data cube. It's an IFU spectrometer Muse. So it's been constructed by collapsing just a few wavelength channels around the Lyman alpha emission of this quasar here, marked by the crosshair. There's some additional sources in the field marked by the X's. So he's made he's made a faux, if you will, narrowband image from that data cube. And indeed, it's quite spectacular. And that same savvy observer will appreciate then that we have a spectrum at every spatial position in this wonderful image from that same IFU. And that's the main result today, which is the velocity map that we can derive from these data. So here that is. The 0 is arbitrary at some level. It's based on the quasar. Blue is blue shifted, red is red shifted. Ignore that stuff. It's low signal noise. If you wish, ignore the data where there's the point sources. That's hard to deal with. But I think you'll appreciate that there's a velocity shear in the data of the order of a couple hundred kilometers per second. And if you want to be speculative, I will perhaps evidence for a rotating baryonic halo of the kind that I believe Kyle will be describing on Friday. Unfortunately, I won't be here, but I ask you to stay tuned for that. And stay tuned for this paper. It'll probably be a few months, probably, before it appears in the literature, but we'll be submitting it before too long. Thank you.
So if the next speaker wants to come up and get ready, then we'll take one question from Andy.
So X, if I look at this right image, I don't see any rotation. I just see two objects moving with two velocities. One 300 with in projection different to the other. In real, it would be probably more like 500 kilometers a second. So why do you think it is a rotating whatever disk or whatever?
I don't.
Okay, so problem solved, easy.
I never would use the word disk, but whether we're seeing, whether we're tracing, but we are tracing the dynamics of that gas on those scales. That's clear. Whether it's related to the angular momentum of the system, I would speculate that's likely. Why not two objects moving? Two objects? What kind of object do you have in mind? Objects? What kind of things do you have in mind, sir?
Well, this is terrific fun, but this looks like a good. Guys, stop. Stop. Okay, I'll try it in German. Stop.